All right. In order to be successful with algebraic proofs, you have to know your properties of equality. On your objective sheet, there were two links to the properties that you need to have memorized. You won't be able to do any of these if you don't have those properties memorized, and if you don't understand them either. Basically, all the properties of equality are justifying what you do. So, for example, addition property. Let's use numbers to make it look a little bit better, make more sense. Let's just say we had 10 equals 10. And we know that is true. The only way we can keep these two sides equal, or how we can maintain the property of equality, is if we add the same thing to both sides of the equation. That's the only way that this equation will be true. So if we add 2 to this side, the only way 10 plus 2 will equal the other side is if we add 2 to the other side as well. So we just call it the addition property. Okay, so anytime you see the same thing being added to both sides of an equation, that's the addition property. Subtraction property, same thing, subtracted from both sides of the equation. Multiplication property, that just means you're multiplying the same thing to both sides. Division, dividing by the same thing on both sides. Okay, when you get to reflexive, a lot of you will struggle with reflexive versus symmetric. Reflexive property is like when you look at yourself in the mirror, that's your reflection, right? So the reflexive property says that you should have the same thing on both sides of your equation, or you should have the same image on the mirror that you would see in front of you. So that's reflexive. That's how you remember that it's the reflexive property. Symmetric property is kind of like, if let's just say that you have a heart, okay, and we're going to pretend that this heart is symmetric on both sides. If I were to cut straight down the middle and fold on that line of symmetry, I would have the same thing on both sides. The two ends would match up. That's what it means to be symmetrical. While symmetric property of algebra or equality, you can almost think of this then as a fold line, where the B would fall on top of the B if you were to fold it, the equal sign would fall on top of the equal sign if you were to fold it, and the A would fall on top of the A if you were to fold it. So that's your symmetric, because it's symmetrical on both sides of the equation. All right, and then the transitive property, I like to think of this as a train. Transitive train. If this is the front of your train, and these are the two cabooses in the middle, and then this is the end train, if those two middle cabooses fall off, you're left with the front of the train and the back of the train. A equal to C. It's exactly like our law of syllogism that we did in, I think, 2 lessons ago, where we said if you have P then Q, and then you're given Q and then a new concept R, remember those two middle terms go away and you're left with P then R. That's the transitive property right there. Two middle terms go away, A equals C. Substitution property, anytime you substitute anything for anything else, that's a substitution property. So for example, if we know that A equals B, then B can replace A in any expression. Another good example of that would be if we know what 9 plus 2 is. We can replace 9 plus 2 with 11. So if I have 9 plus 2, I can substitute that for 11. And then finally, to the distributive property. Remember, the distributive property is when you have a set of parentheses or you have an expression, and then outside that expression, you're multiplying a value. So you're going to distribute the A to the B and do A times B. And you're going to distribute the A to the negative C, and it becomes negative AC. All right, so let's see what we actually are going to be doing with this. Naming the property of equality that justifies each statement. Okay, so if we look here, we have 3x divided by 3 and 120 divided by 3. Well, clearly what we've done on both sides of the equation is we've divided by 3 on both sides of the equation. So this is going to be your division property. Okay, and if you don't want to write out property of equality each time, you can just abbreviate and say POE. So we definitely must write out the entire word division. Do not abbreviate that word, but the POE you can abbreviate. All right, let's look at the next one. If 12 equals AB, then AB equals 12. Well, right here, kind of our line of symmetry. If we were to fold along that, then the AB would fall on top of the AB, and the 12 would fall on top of the 12. So this is going to be your symmetric property. And as you can see, I just abbreviated the property of equality to POE. All right, number 3. Go ahead and look at your list of properties that you should have in your notes right now with the examples up here and see which one this looks most like. Okay, take a second to pause the video, see if you can come up with the correct answer before I do. Okay, and you should have had the transitive property of equality. Remember the transitive property, you have your two terms that match in the middle. You can get rid of those and you're left with the first equal to the third term. So AB equals CD, that's your transitive property. Okay, number 4, look at this one carefully. It looks like there's a couple things going on, but what is happening to both sides of my equation? Okay, take a second, pause the video, look at your notes, and see if you can figure out which one this is. All right, and you should have had the addition property of equality because we are adding the same thing to both sides of our equation. All right, number 5, hopefully this one's easy. In the past, this has always been the easiest one. How are we getting from this original if to this original then? What's changed between the if part, your hypothesis, and the conclusion? Okay, take a second, pause the video, see if you can figure this one out. And this is your distributive property of equality. We have taken the 3 and distributed it to the x to get 3x here. And we took the 3 and distributed it to the positive 2 to get a 3 times 2, which is a positive 6. And then the 42 just stays the same because we haven't performed any operations. All right, my last one, number 6. This one is very tricky. I dare you to get it right. Pause the video and tell me what you think. And this is the substitution property of equality. And if any of them kind of really messed you up, it probably was this one. This one's a little bit trickier. Okay, I'll go ahead and show you how this is the substitution property. All right, here we have x plus y equals z. Then we're told that z equals 30. So this z and this z we were given that z equals x plus y, but z also equals 30. Then in the next statement, we replace this z here, right here, with 30. So now we have, instead of the z here, we have a 30 here. We've substituted in, instead of writing z, we've replaced it with 30. All right, this is also a trick question. This actually has 2 answers. Notice once again that we have the z and the z are back to back, and then they go away. And once they go away, cross them out, we're left with the first x plus y equal to the last 30. So you also could have had transitive property. So don't beat yourself up if you didn't put substitution property. This was a trick question. And there are very few cases where you will have 2 answers. You'll see it with the substitution property and the transitive property. But distributive property, addition property, symmetric, reflexive, division, all the other ones, you're never going to have 2 answers. You'll know for sure which one it is. But substitution and transitive can usually be interchanged. Okay, let's try number 7. How do we get from the if, oh, that's ugly. How do we get from the if to the then? What has happened between here and here? Take a second, pause the video, and tell me what you think. Okay, and this is the addition property of equality. And how we got that is if you notice from here to here, we would have had to add 7. Oh, this is getting sloppy. That's better. All right, we would have had to add 7 to both sides of the equation to get -7 and 7 to be 0 pairs. And then 29 plus 7 is 36. So that's the addition property of equality. All right, try number 8. How do we get from the if to the then? What has to happen between here and here to reach our conclusion? Take a second, pause the video, and tell me what you think. All right, and this is the subtraction property of equality. And we're just doing algebra here, folks. We are not doing anything new or surprising. You're just telling me, if you were to be given this equation originally, if I just wrote this part of the equation up originally and I said solve for x, what would your first step be? And your first step would be to subtract 5 from both sides of the equation. That would give you your 0 pair here. See how you're left with nothing? And then that would be -22 minus 5, which is your -27 here. So you're just doing algebra, but instead of just doing the math, you're justifying what you did to get there. And that's what a proof is. All right, try number 9. How do we get from this side of the equation, the if, to our conclusion, the then? Pause the video and tell me what you think. All right, and this one is a little bit tricky, especially if you were very weak in algebra, because a lot of you may not have remembered that in order to reduce a fraction or to get rid of a fraction here, you have to multiply by the denominator being the number on the bottom of the fraction, that 9. In order to get rid of the 9 in the denominator, you have to multiply by 9 in the numerator. And remember, when you multiply one thing on the left side of an equation, you have to multiply the same thing on the right side. So 9 over 9 gives you 1x. That's right here. And 9 times 2 gives you 18. So that's your multiplication property. All right, last one, and then we're going to try a formal proof, and that is going to help us end up our unit and get ready for our test. All right, so number 10. Hopefully this is a real easy one. Pause the video and tell me what you think. Okay, and we have the distributive property of equality. Remember, distributive property says you distribute something to an entire expression. So this is our expression, and we're multiplying 3 to the x, and we're distributing the 3 to the positive y. So 3 times x is 3x. 3 times a positive y is 3y. So that's distributive. All right, so now that we're getting a better grasp on our properties, we're going to get into doing proofs. And that's going to basically be doing step-by-step, in this case algebra, later on it'll be geometric terms, but step-by-step equations without showing all the work. Instead of showing all the work, we're going to justify it. And you can show the work off to the side, like I'll be doing, but we need to justify it. So up here it says the name the property of equality or congruence. Congruence, we haven't really talked about that yet, but that is geometric terms for equality. But right now we're only focusing on algebraic equations, so we're talking about equality. All right, so just like we had up here with our if-then statements, if, then up here, pretend that's what this says. If 2x plus 9 equals 19, then 2x equals 10. And you're still asking yourself the question, how do we get from here to here? That is our reason. So in order to get from 2x plus 9 equals 19, or if I just gave you this equation, your first step would hopefully be to subtract 9 from both sides of the equation. So we're going to start by subtracting 9. And you'll see that 9 and a -9 is 0, so that's gone. And 19 minus 9 is 10. So all we've done here is the subtraction property of equality. Okay, so for example B, same thing. How do we get from here? So if 3x equals 150, then x equals 50. So you need to figure out what operation has been performed to get x is 50. And what do you think it is? Okay, and that is the division property of equality. if you were to be given this equation 3x equals 150, your first step would have been to divide by 3 on both sides of the equation. So 3 divided by 3 is 1. That's how you get 1x here. And 150 divided by 3 is 50. There you go. All right, C. This should be easy. Pause the video and see what you come up with. And this is the distributive property of equality. We have taken the 2 and distributed it to the quantity 1/2 x minus 5. So we have to do 2 times 1/2. Well, 2 times 1/2, the numerator and the denominator reduce to 1. So we're left with 1x. Remember, we don't write 1x, we just write x because it's understood that there's only 1. And then we still have to do 2 times -5, which gives us -10. And then nothing happens to the 20 because there was nothing being multiplied to it. All right, so now let's get to the big boy proof. You're going to see in the future, they're called two-column proofs, where in one column right here, you're going to have your statements. And then in the right column, you're going to have your reasonings or your reasons. The first reason is always given. Why is 5x plus 3, or 5 times quantity x plus 3 equal to -4? Well, because I gave it to you. That's why. Now, how do you get from 5x plus 3 equals -4 to 5x plus 15 equals -4? So how'd you get from here to here? Well, tell me by writing it here. And what do you guys think? So in order to get from step 1 to step 2, we can call this step 2, we'd have to distribute the 5 to the x, got 5x, 5 to the 3, we got 15. Nothing happened to our -4. All right, we're still solving for x. Our goal here is to get x by itself. How do I get from 5x plus 15 equals -4 to this next step, 5x equals -19? Tell me by writing it here. Okay, and that's going to be your subtraction property of equality, because I would have subtracted 15 from both sides of my equation. 15 minus 15 is 0, so that's why we're left with 0 here. -4 minus 15 is a -19. All right, last one. How do I get from 5x equals -19 to x equals -19 divided by 5? And I would have to have divided by 5 on both sides of my equation. So 5 divided by 5 is 1. That leaves me with x. And -19 divided by 5 is just -19 divided by 5. Now, if you had seen it, I'll go one step further. If my next step said x equals -3.8, sorry for the sloppiness. If it had said x equals -3.8, to get from here to here would have been the substitution property, because I am substituting this value, -19 divided by 5, for its decimal form, -3.8. All right, number 2. Go ahead and on your paper, just start off with writing on the left side of your paper, write all these down, and on the right side of your paper, you should have line paper, so you're just writing the reasons. Remember, your first reason, always going to be the same up here. So take it's going to take you about 3 or 4 minutes to finish this one. So you want to pause your video, and then I'll have the answers up for you then. Good luck. All right, in this order, you should have had given, distributive, addition, subtraction, and division. All right, for those of you that got this all right, go ahead and move on to the practice worksheet and then onto your quiz. For those of you that did not, let's go through and explain why. First one, why is 3n plus 4 equal to 42 minus 3n? I told you it was. It's a given. Okay, how did we get from the first step to the second step? Well, notice here there was a set of parentheses, there was a quantity, and then down here it's gone. So what we ended up doing was we distributed the 3 to the n, so 3n. We distributed 3 to the 4, so a positive 12. And nothing happened on the left side or the right side of the equation. This is the distributive. All right, step 2, how did we get from step 2 to step 3? Well, what happened here? Notice this guy is gone. Well, the only way to get rid of him or to give him a zero pair would be to add 3n to both sides of the equation. So -3 and a +3 is 0. That's where he went, 0. And 3n plus 3n is 6n. And that 12 stayed the same, and that 42 stayed the same. So we added 3n to both sides of the equation. Next step, see how we have a 12 here, and then down here it's gone. And then 42 is smaller. It's now 30. We had to subtract 12 from both sides to get from here to here. 12 minus 12, 0. That's why it's gone here. 42 minus 12 is 30. That's why 42 is decreased. So we had to subtract 12 on both sides of the equation. And last step, how do we get n by itself? Well, we must divide by 6 on both sides of the equation. So 6 divided by 6 is 1n, and 30 divided by 6 is 5. All right, so now that we've got that covered, let's work on our practice worksheet and our exit quiz, and we'll be ready to start studying for our test. Good luck.